Now the next assembly that we are going to create is quite a popular one, and if you are from mechanical engineering background, you will definitely pinpoint its name. It's slider crank mechanism. Now a slider crank mechanism is designed in such a way that it converts straight line motion to rotary motion and rotary motion to straight line motion. There are many applications of this mechanism like reciprocating pumps, rotary engines, piston cylinder arrangement, and the list goes on and on. So let's create this particular assembly. Now for this we are going to have a different approach. We will create a component from the assemble toolbar. Let's name it base, and then just create a box. We have box, cylinder, sphere, torus, coil and pipe. These are the pre-made entities in Fusion 360. You can directly create them. So let's create a box on any of the horizontal plane. Let it be of any dimension, because all the assemblies that we are creating in the course are not two dimension. Now next we have to create this slider over this base. So activate the head assembly. Create new component as slider. And then again select box. Select this face and just create a rectangular box. Click on OK. Now again activate the head assembly. Let's save the file so that our head assembly can have a name. Let's name it slider crank. And as you can see, the name of the head assembly is changed. This is done to just avoid any confusions. Now as you can see, the head assembly is activated, so both of the components are visible. You can move them around. Just revert the position to revert it back to the original position. And now whenever I am making any changes on any of the components, the other component might also get affected if it is getting in the way of the sketch. So notice whenever I am going to make any changes in one of the component, the other component will also get affected. Only if the sketch entities that we are creating overlaps with the other component. So let's say we are making a circular hole over this one. Let's select the midpoint of this edge and just create a circular hole of let's say 8 mm diameter. Finish the sketch and let's select the region and cut it through so that we can put a pin in this one. So notice the changes that we are making in this component is not making any changes on this component because the sketch entity is very far away from this one. But if this sketch entity was somewhere between this junction, then both of the component could have got this through cut. This we have seen in previous assemblies as well. So just press on OK. And now let's switch to the next component. This is our stroke. But prior to that, let's create this particular pin. Go to assemble toolbar, new component. Let's name it base pin. Select this face, invoke the circle command. Let it be 8 mm only. Finish the sketch. Left click, right click, then select press pull, and let's extrude it up to an object. So that means extend type is to object, and click on OK. Now from this particular face, right click, press pull. Let it be like 10 mm only, and press on OK. Now again activate the head assembly and see we have 3 components as of now. Now here let's create this particular stroke. As the name suggests, this component that we are going to create will define up to how much extent this slider will slide. So let's create a new component. Let's name it stroke. Now from this particular face of the pin that we have created, the base pin basically, let's create a circular sketch entity. Let it be of any dimension, and then trace this center point up to which you want the stroke. This defines the stroke length. You can change it to your choice depending upon the length up to which basically the extent up to which you want this particular slider to slide. Now create one more circle. Let's make it a bit smaller as compared to the larger circle over there, and then join the outer circles with line command. Just keep in mind that tangency has to be maintained. So whenever tangency is not maintained, you can always look into this tangency constant, select the line, select the circle. Again here also select the line, select the circle. Now let's trim some unwanted areas and we are good to go. Finish the sketch. Select this profile, right click, press pull. Let it be like 5 mm in this side and click OK. So our stroke is also created. Next we need a small modification on this slider component. What we will do, we will create a pin over this one, a inbuilt pin basically. We are not creating a separate component, we are creating something that is inside of the component, which is a part of the component. So just create it here. Just select this face and invoke the circle command. So first here what we will do, we will create a center line from the center of this edge to the center of this edge. Let's convert it to center line from the sketch palette. Now from the center of this one, let's create a circle of, let's say, 5 mm. Finish the sketch. Now here you have to make a certain geometrical adjustment. As we know, we are having this particular pin protruding out by 10 mm. So we will create the pin over here, which is not a component, which is the part of the slider itself, more than this 10 mm over here. So let's make it like 15 mm and click on OK. Again, the changes done in this component doesn't affect any other component, because this was the sketch entity that we have created is not overlapping with any other component. Now the only thing that is remaining is to create a connection between this particular stroke and this pin. So let's create a connector. Select this face, invoke the circle command. Let's create a circle and then create an outer circle that can have any dimension, but for the sake of proportionality, let's make it similar to the stroke one. Now here we have to make a certain adjustment. As we can see, we cannot pinpoint the center point. The center point is highlighted with a circular notation, which is not visible here. This crosshairs are there, but it is not 100% sure that this will be the center point. So what we will do, we will go to create and project, and this time we will project this particular sketch entity. In the selection filter, you can see you can project bodies that we have done earlier in the earlier assemblies, and you can also project sketch entities of the previous component or the components that is hiding behind the shadows. So just click on OK here because we need a sketch entity only, and it will be highlighted. Now let's create a circle bigger than this one and invoke the line command, and let's join these two. And do not forget to maintain tangency. You can see this tangency constant. Just click left click so that the tangency is maintained. From here also. Now here the tangency is not maintained, so just click on tangent constant, select the line, select the circle, select the line, select the circle. Now trim some unwanted areas. Let's trim this and this and this, and we are good to go. Just finish the sketch. Select this, select control and select this one also. Right click, press pull, and we know it is like 5 mm more than this particular point, so we can write 5 here, and our connector is also ready. Now the only thing that is remaining is to create a pin over here. So for this, let's create a new component. Let's name it common pin. Select this face, invoke the circle command. As you can see, the center point is visible with this circular notation. Let's finish the sketch. Right click, press pull, and then extend type to object. Select this particular surface and click on OK. So finally all the components are ready. The only thing that is remaining is to create joints and complete the assembly. So as of now, we don't have anything grounded, so we can move all the components. There is no joints, they are free to move, and you can always revert back to the original position by clicking this one. Or if you want certain different orientation of the assembly, let's say you want all this over here and here and here and here, so that you can see all the components, you can also click on capture image, so that if you make any changes and then revert, it will be reverted to the captured image that you have done. But we don't require that. Just Ctrl Z. Now let's create the assembly. For this, let's ground this base first. You have to ground at least one component. Now click on joint, select this base pin and select the base and let the motion be rigid. Again create joint. You can press J in the keyboard as well. Between this and this pin itself, the motion as revolute. Next, a joint between this common pin and your stroke. Next joint between the common pin and the connector. Again, motion is revolute. And then between the slider and this connector, again revolute only. And finally the most important joint, slider one, between the slider, just select the edge and notice that here the icon for placing the joint origin is quite fluctuating. So you have to be very vigilant here. You have to see the orientation. If the edge is like perpendicular to the joint origin, that means you are good to go. But if it is not, your joint will be messed up. So always make it perpendicular like this. Select this again. For the base, we have to do the same drill. And as you can see, the slider joint is created. Click on OK. Now let's try to rotate this. Yeah, I think we are good to go. But we need a slight modification because this is going out of the base. So what we will do, we will just press pull it outwards. And now our assembly is fully complete. Just select any of the joint, right click and animate the model to see the result.